Okay, we'll pick up with our Unit 4 review of polynomials with question 12 from the review, which asks us, this is actually a review of Unit 1. This is asking about transformations. It says, here's our parent function x cubed. We want to describe the transformations that turn it into 2 times x minus 3 cubed plus 4. We have the same basic transformation pattern as we had in Unit 1, no matter what our parent function is. Our parent function here is cubed, but it still works the same way. I have a number in front being multiplied. That would be my stretch or compress. I can have a number inside with x. That's going to be a left or right movement, depending on what I'm subtracting. And here, my parent function is just cubed. So the cube doesn't mean anything for our transformations. It just tells me what the shape of this graph is going to be. And then at the end, I can add something to bring my function up or down. So let's see what we have in this equation. We have a 2 in front. That's going to be a stretch. If that was a fraction smaller than 1, like 1/2, that would be a compress. But this 2 is going to stretch us out to double our original height. So this is a stretch, and we'll say it's a stretch by 2. By 2. Up next, I have a minus 3 inside my parentheses. Now, the minus is supposed to be there. So when I see that minus, I'm going to be moving to the right. If I had a plus sign in there, I would be moving to the left. So the minus 3 moves me to the right 3 spaces. Last but not least, I have this plus 4 at the end. That's my k value. That's going to be moving us up or down. And since it's positive, we're going to be moving up 4. So that takes my graph of f of x equals x cubed. It moves it to the right 3, up 4, and then it stretches it out twice as tall. Let's take a look at question 13. This is asking us to evaluate some operations here. Now, f plus g of x, for example, a, f minus g of 0, for example, b, and f times g of 2, for example, c, are literally just the operations plus, minus, or times. I don't have to go and multiply by x or numbers at the end like this. This is not times x. This is of x, just like the notation f of x. It just tells me what I'm going to be plugging into these formulas. For example A, I have f plus g of x, and since it still has an x in there, that tells me that my final answer will still have an x in there. And all I have to do to get my final answer is take f of x and add g of x. That's it. So let's start with f of x. It is this equation here, 3x squared plus 4x plus 5. I will add to that plus g, which is this guy, 2x squared plus x minus 2. All I have to do is combine my terms, and this problem is finished. 3x squared plus 2x squared is 5x squared. 4x plus x is 5x. And 5 minus 2 is 3. So that's my final answer for problem A. Now for problems B and C, the difference you're going to see here is instead of having this of x at the end, I actually have of a number. And there's two different ways to solve these problems. You can either do the operation first with just x in, like we did for example A, and then plug in the number they've given you at the end, or you can plug in the number they've given you first and then do the operation. And I actually think that way is much, much easier. So, for example, B, I'm not going to do f minus g first and then plug in 0. I'm going to plug in 0 first and then do f minus g. So I'm going to do f of 0 minus g of 0 to find out what I get. I'm going to plug in 0 for both. If I do f of 0, I get 3 times 0 squared plus 4 times 0. Both of these cancel to just 0. Plus the number 5 at the end. So f of 0 is 5. For g of 0, I'm going to have 2 times 0 squared plus 0 minus 2. Again, everything here will cancel except the number minus 2. So for my f of 0 minus g of 0, all I have to do is my 5 minus this negative 2, which ends up being 5 plus positive 2, which is 7. And we have our final answer. All right, for problem C, this is immensely easier if we do our of 2 first and then multiply our answers together. So I'm going to do f of 2 times g of 2 instead of multiplying my equations first and then plugging 2 at the end. So to find f of 2, I'm going to do 3 times 2 squared plus 4 times 2 plus 5. So 3 times 2 squared is 3 times 4, which is 12. 4 times 2 is 8, plus 5, and altogether that gives me the number 25. So f of 2 is 25. To find g of 2, I'm going to have to do 2 times 2 squared plus 2, and then the equation has a minus 2 at the end, so these guys are actually going to cancel. So all I have to do is 2 times 2 squared. 2 squared is 4, times 2 is 8, so g of 2 is 8. So for this problem, all I have to do is whatever f of 2 was, 25, times whatever g of 2 was, which is 8. 25 times 8 is 200, and I'm done. All right. Let's go ahead and take a look at question number 14. For question 14, this is asking me, is this expression true? So all I have to know is, does the left side actually equal the right side? And I have two different ways of finding this out. The left is factored, the right is not. So I could either factor the left, multiply back together the left, or I could factor the right. Either way is totally acceptable. So if I multiply together the left-hand side, I recommend, just like we did earlier in this review packet, I recommend FOILing first and then taking care of the x at the front. So if I FOIL here, I get x times x, which is x squared, x times 2, which is 2x, negative 3 times x, which is minus 3x, and negative 3 times 2, which is minus 6. And when I combine my like terms, I get x squared minus x minus 6. That's those two terms multiplied. And then I can multiply by the x that I had, which gives me x cubed minus x squared minus 6x. You'll notice that's exactly what I have on the right-hand side here, x cubed minus x squared minus 6x. So this is true. Yes. If you decided to solve this by factoring instead, you could take this equation, x cubed minus 2x minus 6, factor out the GCF x, which gives you x squared minus x minus 6, and then use a t-chart to find two things that multiply to this negative 6 that add to this negative 1. The factors are 2 and 3, and since they're opposite signs and need to become a negative sum, I'm going to make the bigger number negative 3 negative and the 2 positive. We're going to end up with an x and a positive 2, and an x with a negative 3, and this x that was our GCF. And you'll see that's exactly what we started with on the left. So either way, you can show that these two equations are indeed equal to each other. All right, one more for this video. We're going to go ahead and take a look at transforming this polynomial and then plugging in a number. Now this has told us which operations to do first. So we are going to do the transformation first, then plug in f of negative 1. So remember that standard form for transformations. Any stretch or compress goes in front, and then comes our x with any left or right movement inside, and then whatever parent function we have. And at the very end, we have any up or down movement. So this says I need to go left 2 units. So for my function, f of x, I'm going to have my parent function, x cubed, and inside the parentheses with x, I'm going to have a number that will move me left 2. The operation that will bring me to the left is a positive sign. Adding brings me to the left. Like Miss Beyonce is a positive influence, and she moves things to the left. And I need to go to the left 2, so I'm doing plus 2. We also need to go up 6. That's my k value at the end, so we're just going to add 6 to the end. So this is my transformed polynomial. It's been moved to the left 2 and up 6. And my last job is going to be to find f of negative 1. So f of negative 1, I'm just going to plug that in. Negative 1 plus 2 cubed plus 6. Negative 1 plus 2 is just 1. 1 cubed is just 1. So 1 plus 6 is 7. Final answer for that problem. All right, we're going to go ahead and pick up with the next question in the next video.